Question number 51. Consider a solution saturated with respect to both Ma and Mb2. The A2 minus ion in the solution is found to be 1.2 into 10 raised to the power minus 3 molar. Then the concentration of B minus ions in the solution is, so we have been given the value of Ksp of Ma and the Ksp of Mb2. So students, this is a case of simultaneous equilibrium. So let us first try and look at these equilibriums. So Ma will dissociate into M2 plus and A2 minus, whereas Mb2 will dissociate into M2 plus and 2B minus. Okay, the Ksp value for the first salt is given to be 6 into 10 raised to the power minus 10, and the Ksp of the second salt is given to be 7.2 into 10 raised to the power minus 15. And we have also been told that the A2 minus ion concentration in the solution is 1.2 into 10 raised to the power minus 3 molar. Okay, so using the first equilibrium, we can find the value of M2 plus ion concentration, and since both of these equilibriums are established simultaneously, the M2 plus ion concentration which we calculate here can be used in the second expression to find the value of the concentration of B minus ions. So let's start with solving the concentration of M2 plus ions over here. So we know that the concentration of M2 plus ions into A2 minus, which is 1.2 into 10 raised to the power minus 3, it should be equal to 6 into 10 raised to the power minus 10. So from here we can get the value of M2 plus ion concentration, which is equal to 5 into 10 raised to the power minus 7. So now the concentration here will also be 5 into 10 raised to the power minus 7. And we can solve for the concentration of B minus ion. So solving for Ksp of the second salt, M2 plus ion concentration into B minus ion concentration whole square is equal to 7.2 into 10 raised to the power minus 15. So this value is 5 into 10 raised to the power minus 7. Which further simplifies to 1.44 into 10 raised to the power minus 8. So on simplification, the value of B minus ion concentration, it will come out to be equal to 1.2 into 10 raised to the power minus 4 molar. So the correct answer for this question is option 2. Moving on ahead to the next question, question number 52. Which of the following set of quantum number is not permissible? So students, we know that L can take values from 0 to n minus 1. Whereas M on the other hand can take values from minus L to plus L. And S can have a value of plus half or minus half. So let us look at the first option. N equal to 2, L equal to 0, M equal to 0, S equal to plus half. This is allowed. Okay. N equal to 4, L equal to 2, M equal to minus 3. So student, this M value is not allowed as the value of L given to us is equal to 2. So the value of M must lie between minus 2 to plus 2. Okay. Let us look at the option 3. Option 3, all of these quantum numbers satisfy the condition, and so do all the quantum numbers given in the fourth option. Okay. So the examiner is interested in knowing the set which is not permissible. So we have to mark option number 2 as the answer for our question. Let us look at question number 53 now. So consider the PV diagram given below for a process which is carried out on 1 mole of an ideal gas. So we have been given a PV graph. So since we are able to draw the graph of P versus V, it means that the system parameters are defined at every instant, which must mean that the process is reversible. Okay. For an irreversible process, the parameters of the system may not always be defined in the intermediate stages. Okay. So looking at the option 2 gets eliminated. So we have established that the process is reversible since we have a proper curve for the system parameters. Okay. Now we have to comment on the enthalpy, that if this process proceeds with a increase, decrease, or no change in the enthalpy of the system. So if we look very carefully, so in the initial stages, the product of P into V is given to us. So initially at this point, the product of P into V is equal to 20. And if we look at this point, the product of P into V is 45. So we can see that during the process, the product of PV increases. So by extension, as the gas given is ideal gas, nRT should also increase. Okay. Now since number of moles is constant and the value of R is also constant, it must mean that the temperature must have increased during the process. Okay. So if there is an increase in temperature, it means the value of H should also have increased, as delta H is equal to NCP delta T. So as delta T is positive, so delta H should also be positive. Okay. So the given process is reversible and it proceeds with an increase in the enthalpy of the system. So the answer which we have to mark for this question is option 1. Let us look at question number 54 now. Consider the reaction which is balanced, A plus B giving us CC and DD. So if initially M moles of A are mixed with N mole of B, then consider the following statement. If M by N is equal to A by B, then no reactant is in excess. If M by N is less than A by B, then A is the limiting reagent. And statement 3 says if M by N is greater than A by B, then B is the limiting reagent. So student, let us try and solve this question. AA plus BB giving us CC plus DD. Okay, so we have been given M moles of A and N moles of B. So students, we know that in order to find out the limiting reagent, we have to find out the ratio which is given by the given moles upon the stoichiometric coefficient. Okay, and whichever species has the least value for this ratio, it will be the limiting reagent. Okay, so the given moles is M and the stoichiometric coefficient is A. So M by A, and here we'll have N by B. So for the first condition, which says that no reactant is in excess, both of these values should be equal to each other. So for condition 1, M by A should be equal to N by B. Rearranging, we have M by N is equal to A by B. So the first statement is a correct one. Let us look at the second condition, for A to be the limiting reagent. So if A is the limiting reagent, it means the ratio which we have calculated should be less for A as compared to B. Now since all of these numbers are positive integers, we can rearrange them without bothering about the sign. So M by N should be less than A by B. So this condition is also correct. Let us look at the third option, for B to be the limiting reagent. This sign has to be just opposite of what we had calculated before. So in this case, M by N should be greater than A by, so which is also again correctly given in the third option. So students, all three of these given statements are correct. So we have to mark option 4 as the answer for this question. Let us look at the next question, question 55. Which of the following statements is correct with respect to the solution obtained by mixing phenol and aniline? So the examiner seems to be interested in the deviation shown by the solution and also the reason behind that deviation. Okay. So in order to solve the question, let's first look at the structures of phenol and aniline. Okay. So phenol is PHOH and aniline is PHNH2. So students, when we mix phenol and aniline, the solution shows a negative deviation from Raoult's law. So the reason behind is that the interaction between the phenol and aniline is stronger. the lone pairs over nitrogen are very strong. And the OH bond polarity is greater in phenol. So greater polar bond means that the delta positive on this hydrogen will be greater as compared to the delta positive on the hydrogen of the aniline. Okay, and if we talk about the strength, these lone pairs are stronger than the lone pairs of phenol. So the interaction between the phenolic proton and the lone pairs over nitrogen in aniline will be strong among all types of intermolecular forces present between these two compounds. So let us look at the options. Statement 1, it shows a positive deviation. This statement is incorrect. Second is also incorrect because it does not show a positive deviation. It shows a negative deviation. So we are left with options 3 and 4. So let us look at the third option. It shows a negative deviation as the H bond between the phenolic proton and lone pair on nitrogen atom is stronger than the respective intermolecular H bond between similar molecules. So this statement is correct. Let us look at the fourth option. It shows a negative deviation as the H bond between lone pair of oxygen in phenol and proton on the N is weaker than the respective intermolecular H bond between similar molecules. So this statement is incorrect because a weaker interaction will not lead to the solution showing a negative deviation. Okay. So the correct answer for question number 55 is option